Have you ever found something out of place and thought, how did that get here? It's a fantastic question. It's the start of science, of discovery, of thinking like a detective. I found myself in just such a situation the other day. On my lab table, sitting right next to a beaker of gently bubbling blue liquid, was a tiny, soaking wet hat. It was a mystery, and to solve it, I knew I would need to use one of my favorite tools. A tool you can use too. That tool is a single, powerful word, deduction. Now, deduction is a truly cool word because it has two very useful but slightly different meanings. Think of it like a multi-tool for your brain. The first meaning is all about thinking logically. It's when you take clues, little pieces of information that you know are true, and you put them together to figure out something you don't know. It's how scientists make discoveries and how detectives solve cases. You observe, you gather facts, and you arrive at a logical conclusion. It's a beautiful process, really. The other meaning of deduction is a bit more straightforward and involves numbers. It means to take away or to subtract. You see this kind of deduction all the time, especially when you're dealing with money or math. If something is on sale, the store makes a deduction from the original price. When you calculate how much money you have left after buying a delicious ice cream cone, you're using deduction. So, it's a word for both solving mysteries with your mind and for figuring out a price with math. Let's explore both with a little story. To help us understand, let's imagine a very special mouse detective. Her name is Dot, and she is an expert in the science of solving small-scale puzzles. She's only about the size of an apple, but her brain is a powerhouse of logical reasoning. She even has her own tiny detective hat, which, coincidentally, looks a lot like the one I found on my table. One morning, Dot noticed a small, peculiar puddle on my kitchen floor, right by the leg of a chair. A dish towel was lying beside it, also damp. This was a case. Dot knew it was time to put her skills of deduction to the test. Detective Dot began her investigation immediately. Science starts with observation, after all. She first examined the puddle. It wasn't just water, it had a faint, sweet smell. She thought. Next, she picked up the damp towel. It smelled sweet too, just like the puddle. Dot then scurried over to my lab table and looked at the tiny, wet blue hat. She noticed a single sticky drop clinging to the brim. She carefully touched it, and then, being a very brave and scientific detective, tasted it. It was sugary. Dot was now using the first kind of deduction, logical thinking. She gathered her facts. Fact 1, a sweet-smelling puddle on the floor. Fact 2, a sweet-smelling towel nearby. Fact 3, a tiny wet hat with a drop of sugary liquid on it. These were her clues, her pieces of evidence. A good detective, like a good scientist, doesn't just guess wildly. They use the evidence to build a logical bridge from the known to the unknown. Dot stood back, stroked her chin, and began to connect the dots in her mind. Who or what could be responsible for this sweet, sticky situation? If the puddle is sweet, and the towel used to wipe it is sweet, and the hat found nearby is also wet with something sweet, then it's highly probable that they are all connected. She looked around for more evidence. Near the table, she spotted a few faint, crumbly footprints. They weren't from a person, they were much too small. They looked like they were made of cookie. She followed the trail from the puddle, up the leg of the chair, to an open cookie jar on the table. Dot smiled. The puzzle was becoming clearer. She made a logical leap based on her facts. Someone small, she deduced, climbed the chair to get a cookie. They were carrying a cup of juice. They must have spilled the juice, creating the puddle. They used the towel to try and clean it up. And in the process, their little hat fell off and landed near my lab experiment. She had used the clues, the smell, the wetness, the cookie trail. Now let's switch gears and look at the second meaning of deduction. This one is all about the numbers. Imagine I went to my favorite science supply store to buy a brand new volcano model kit. It's awesome. Baking soda vinegar and even a little plastic palm tree. The price tag clearly said $20. That was the starting price. I took the box to the checkout counter, ready to pay the full amount. But wait, the cashier scanned the box and a light flashed on their screen.
Fantastic news! All volcano kits have a special $5 deduction today.
A deduction. They weren't adding $5. They were taking $5 away from the total price. This is the mathematical meaning. A deduction is a subtraction. It's an amount removed from a total, making the final number smaller. Pay stubs, sale signs, math homework. The original price was $20. The store applied a $5 deduction. 20 minus 5 equals 15. My final cost was only $15. That $5 amount is called the deduction. It's a real-world subtraction that saves you money. It's key in budgeting and finance. Even our tiny detective, Dot, understands this perfectly. She keeps tiny coins she finds under the sofa cushions in a little thimble. She started the day with 10 shiny coins. She found 2 more. Now she has 12. She bought a crumb of cheese for 1 coin. 12 minus 1 equals 11. Back in the lab, Detective Dot was quite confident in her logical deduction about the spilled juice, the cookie thief. She had identified the culprit, a mischievous squirrel named Squeaky, known for his love of sweets and his tiny blue hat. But a good scientist and a good detective sometimes test their conclusions, even the silly ones that pop into their heads. Dot looked at the wet hat, then at the bubbling blue liquid in my beaker on the lab table. A truly wild idea sparked in her mind. What if my first deduction was wrong? What if the hat didn't just fall off? What if the hat itself was a tiny boat trying to sail across the beaker of blue liquid? This was, of course, a very silly hypothesis. The hat was made of felt, not wood or plastic. But sometimes testing a silly idea can be fun, and it can help confirm that your logical idea is correct. It's part of the scientific method. Form a hypothesis, then test it. With great ceremony, Dot pushed a small stool to the lab table. She carefully picked up the tiny, wet hat. She held it over the beaker of bubbling blue stuff, which was just colored water for a density experiment. "Prepare for launch," she whispered dramatically. She then dropped the hat into the beaker. Did it float like a tiny blue sailboat on a fizzy sea? No, it did not. The felt hat immediately absorbed the water, became heavy, and sank straight to the bottom with a sad little plunk. Dot burst into giggles. Her silly hypothesis was officially busted. The hat was definitely not a boat. This little experiment, while funny, served a purpose. It eliminated an alternative and ridiculous possibility, making her original logical deduction even stronger. The evidence still pointed to Squeaky the squirrel and his spilled juice. The failed boat test was a funny footnote in the case file, a reminder that science can be playful, and being wrong can sometimes be just as informative as being right.